Welcome once again to Physics and Mathematics Lovers. Today, I want to solve a question on this topic, thermal energy, precisely a subtopic in it. And this topic is talking about mixture, the principle of mixture. So remember, the principle of mixture simply says that the total heat loss is equal to total heat gain. Good. So in our mixture, it's either a hot object is put into a cold object. And when a hot object is transferred into a cold object, the hot object will lose a reasonable amount of heat, while the object which is cold will gain the heat. So in our calorimeter, the system of measuring the heat, so what actually happens is that the total heat that is lost by a hot object is equal to the number of heat, the amount of heat that is gained by a cold object. So on this perspective, I want us to solve one question on this topic. But because of space here, there is no space, and the question is very bulky. So I'm going to display it on the screen so that we read through. So I will be reading it here as I display it. The question says, consider a copper of mass 50 kilogram at temperature 10 degrees Celsius and a copper calorimeter of mass 15 kg with water to weigh 40 kilogram. When heat energy is supplied to the calorimeter until temperature reaches 50 degrees Celsius. Find the specific heat capacity of the copper, given that specific heat capacity of water is 4,200 joules per kilogram per Kelvin, and that of copper is 400 joules per kilogram per Kelvin. Now, initial temperature of calorimeter is 54 degrees Celsius. Mass of water is 25 kilograms. So you can see that this question is very bulky, but I tell you, it's going to be very easy. Let's begin to analyze each and every one of them, the information given to us in this question. Now, the first thing that you need to look at there, so we are talking about mixture now. So the first mass that is given to us here for the question, say a mass of what? 50 kilogram of copper. So we can call it M1. Let's use M1 to denote it. M1 is equal to, so let's divide the board, okay? M1 is equal to mass of copper. Now, let's call it a mass of copper. Mass of copper is equal to, what is it giving to us? 50 kg. So it's 50 kg. Okay, we have that. Then the next one, we are giving our mass of calorimeter 15 kg. So we can use M2 to represent mass of calorimeter, which is what to mass of calorimeter. Okay, equal to what? 15 kg. Now the next one that is given to us here, mass of water. We are given that the mass of water is 25 kilogram. That is M3. Let's use M3. Since we are having three different quantities there. So M3, that is mass of water. Mass of water is equal to 25 kilogram. Okay. Then temperature is given. Look at a copper. The initial temperature is which is 10 degrees Celsius. So we can call it theta 1 equal to initial temperature equal to, we have 10 degrees Celsius. All right. Then now let's theta 2 represent the initial temperature of calorimeter. So from the question, they said that the initial temperature of the calorimeter is 54 degrees Celsius. Then after the whole system, the final temperature of the mixture now becomes 50 degrees Celsius. Then specific heat capacity of copper, so which is what we are looking for. So we let C1 be equal to the specific heat capacity of copper. We don't know it. Okay. Then C2, we are given that the specific capacity of water is 4,200 joules per kilogram per Kelvin. Okay. That is for that. Now let us represent C2 by what? Specific heat capacity of water. Okay, that is for C2. Then C3 is equal to the specific capacity of calorimeter, which was used for the experiment. So here is 400 joules per kilogram per Kelvin. Now, according to mixture, for us to get this specific heat capacity of this copper. So according to mixture, the total heat gain from the law of mixture. So let us minimize the board here. So we are going to minimize the board. Please bear with me. So according to mixture, heat gain is equal to heat loss. That is what? Heat loss, HL. So you can call here Hg equal to what? HL. Heat gain equal to heat loss. Now let us look at the body. The first thing is to identify which body is gaining heat. Now it is the copper that is transferred or that was transferred into the calorimeter is the one that is gaining the heat, because water and the calorimeter was already heated. So now a cold copper was transferred into it, meaning that what? Heat gained by copper is equal to heat loss by water and what? Heat loss by what? Calorimeter. Now, how do we calculate the heat gain? Heat gain here by what? The copper is equal to what? M, the mass of that object, which is M1, because we said that the mass of copper should be what? M1. Then multiply by the specific capacity of that body. Then times the change in temperature. Change in temperature now will be equal to the final temperature of the system now minus the initial temperature. Theta 1 here is initial temperature, which is what? 10 of what? Copper that was dropped into the system. Now, where is the final temperature? That is what? Theta 3. So here is going to give me what? Theta 3 minus what? Theta 1. Good. So this is your heat gain. This is the heat gain now. So let us calculate it from here. So if we say that what the mass there is what? 50. That is what? 50 times, okay? Now, what is the specific? We don't know. That is your C1. Then, what is our theta 3? Is what? 50. 50 minus 10. Okay, so that's that. Then, minus this, going to give you 50 times C1 times what? 50 minus 10 is what? 40. Okay, now 50 times 40 is going to give you what? 2000. Okay, now let us look at it. So this is what 50 times 40 is what? 2000 C1. So this is your heat gain. Now let us go to the system now. So two bodies there lost heat. Number one, water lost heat. Now let us look at heat loss by water now. We call it HL, then by water. Remember, heat loss by water is also the mass. What is the mass of water? Mass of water is M3. Okay, M3 is M3. Then multiply by the heat capacity, specific capacity of water is what? C2. Okay, C2. Then multiply by the change in temperature. Now, temperature is now falling. What was the initial temperature? The initial temperature was, okay, now let's go. The change in temperature is equal to what? Theta 2. That is what? Falling in temperature. Theta 2 minus what? Theta 3. So because when there is heat loss, there is going to be falling of what? Temperature. So that is that. Then, what is our M3? Look at it from the question here. M3 is what? 25. So we got 25 times. What is our C2? C2 here is 4,200. 4,200. Now multiply by what is the falling of the temperature? Where is your theta 2? Theta 2 is initial temperature of the calorimeter, which is 54. Now, what is our theta 3? 50. Okay, good. So now times what? 54 minus 50. Okay. So at the end of the day, you got 25 times 4,200 times 4. Okay, so this is heat loss by water. This is what we got here. We multiply everything. We are going to compute it. The next body that lost heat is calorimeter. So we're going to look at heat loss by the calorimeter. That is calorimeter. Is equal to, remember, the mass of calorimeter. What is the mass of calorimeter? Mass of calorimeter is M2. The mass of calorimeter multiplied by the, what is the specific capacity of calorimeter? C3. Then temperature falling. What is the temperature? So that means temperature will be what? Theta 2 minus what? Theta what? 1. Okay. So that is what we are going to have there. So the heat loss by calorimeter. Now let's go. What is our theta? What is our M2? M2 here, I have M2 is 15 kg. 15 kg times, what is our C3? Is 400. C3 is 400 times temperature. What is that going to be? Okay. Now, what is our theta 2? Theta 2, where is theta 2? Okay, let me check it here. Theta 2 is 54. 54 minus, okay, sorry, this here, this is not supposed to be, this is supposed to be theta 3. Okay, because there is falling of temperature. So it's going to be minus 50. Okay, so which will now give us 15 times 400 times 4. Okay, so remember, we are going to work with total heat gain. There's only one body that is gaining heat here, equal to total heat loss. So two bodies here lost heat, water and the calorimeter. So we add everything, then we get our C1. Okay, so here we are going to have 2,000 for heat. We said our heat gain equal to what? Heat loss. Okay, now here we're having two types of heat loss. So heat gain is what? 2,000 Ci, C1, 2,000 C1 equal to, now let's multiply this. Multiply 25 times 4,200 times 4. So what will it give to us? It's going to give us 105,000. Then let's multiply this now. This times 4. It's going to give us plus 24,000. Okay. So let us add the both of them. So we're going to have 2,000, then C1 equal to, at the end of the day, we're having 129,000. 129,000. Okay. Then we are looking for this. Let us divide both sides. Divide both sides by 2,000. Then this is gone. So we're going to have here, divide by what? 2,000. So this is gone. At the end of the day, we're going to have C1 equal to 64, which means here 129 all over what?